It's good to see you all survived part 1. Now part 2, now don't forget we are trying to simplify this. Solve this without a calculator. Now radians are a little bit trickier to do. What we need to do is come up with a way to simplify this in terms of a known radian measure. Angle degrees are pretty easy, but radians are a little harder. So sometimes what I tend to do is I want to think of what can I add. They both need to have a pi over 12. I'm using a common denominator, pi over 12. And I want to put something up here, up top, that will reduce the 12 to something I know, like a pi over 2, a pi over 3, or a pi over 4. I know those. I don't know anything pi over 12. So what I might do is I might say, oh, if I let this be 9, now I'm just guessing here, 9 pi over 12 will reduce to 3 pi over 4. But what do I have to add to 9 to get me 13? I have to add 3 to 9, so I'm going to put my 3 over here. And I see, will that reduce? 3 pi over 12? Oh yeah, that does become pi over 4. So that's pretty nice for us. Now, you may be thinking, Mr. Warnow, but will anything work? Well, let's try it. What if we made this a 5 and this a 7 instead? 5 and 7. They do equal 12. Whoops, let's make that a 5 and an 8. Sorry about that. That they do equal 13 when you add them together, but 5 pi over 12 doesn't reduce, and we don't know what 5 pi over 12 is, so that one won't work. You want to use ones that will work. So I could write this now as the cosine of 9 pi over 12 plus 3 pi over 12. But remember, I should reduce that to what I do know. That's 3 pi over 4 plus pi over 4. Pi over 3. That's awful. There you go, pi over 3. And now remember this is cosine, so I'm going to write this as the cosine of 3 pi over 4, the cosine of pi over 3, minus the sine of 3 pi over 4, the sine of pi over 3. And I just simplify that. Cosine of 3 pi over 4 is root 2 over 2. We are in the second quadrant, so that's negative.
Please call 47044, Coach Chauvin. Please call 47044.
Yes, please, Coach Chauvin. Please call. All right, now, cosine pi over 3, we should know what that is. That is 1/2 minus, again, here's root 2 over 2. Sine is positive in the second quadrant, so it stays like this. And the sine of pi over 3, root 3 over 2. I just simplify. They both have our common denominator for the top here, negative root 2 minus root 6. And there's our answer. Very easy to do. I would try this one again, maybe make up a couple of your own. All right, now, let's go and simplify this one. These are very easy to do. People always get confused. What do I do? What do I do? Very easy. This is just my rule. This is sine. I'm subtracting, so I'm going to use the same rule. So this becomes the the cosine of 3 pi over 2 times the sine of x. Be careful, same, plus, or minus, the sine of 3 pi over 2, and I get the cosine of x. Now notice I did kind of switch those around, and that's okay. As long as you get them right, you can do cosine, sine, sine, cosine. It doesn't matter. Orders doesn't matter here. Now, the cosine of 3 pi over 2, that's 0. This whole term side is just 0. The sine of 3 pi over 2 is negative 1 times the cosine of x. So what do we get? The cosine of x. Very good. All right. And we can even use these to solve like really cool equations, like right here. I'm going to use my sine rule. This becomes cosine x, sine pi over 2, plus the sine of x and the cosine of pi over 2, plus, expand here now, the cosine of x, the sine of 3 pi over 2, be careful, minus this time, be careful, the sine of x, the cosine 3 pi over 2 equal to 1. Wow. Did I run out of room there? All right, just simplify. This is just 1, so we're left with the cosine of x here. The cosine of pi over 2, that's 0. So that whole term becomes 0. Plus the sine of 3 pi over 2, negative 1. So this becomes minus cosine of x. Minus, interesting, minus the sine of x, cosine of 3 pi over 2. And, well, again, that's just 0. So that becomes minus 0 equals 1. And if you notice, everything on the side cancels, and I get 0 equals 1. Well, can 0 equal 1? No. Therefore, there is no solution for this one. Okay, very easy. Now, what if this would turned out to be a plus cosine of x? A plus right there instead. Well, in that case, we would get 2 cosine of x equals 1. And you can solve cosine of x equals 1/2. Easy to do. All right. Down below, we're just going to do maybe 1 or 2 of these. All right, thank you. All right, so we have the sine of alpha equals 3/5, and they have the tangent of beta equals negative 5/12. Now, they tell me alpha lies in quadrant 2 and beta lies in quadrant 4. So what we're going to do here is we're going to draw these triangles. Now, we've done this before. For the sine of alpha equals 3/5, we're going to draw that in quadrant 2. Here's alpha. It's the opposite, remember that's my opposite, over my hypotenuse. So it's 3, and there's 5. Now, the adjacent is going to be negative 4. It has to be negative because it's in quadrant 2. So that makes it negative, makes my x value negative. Now, tangent's in quadrant 4. Now, tangent, remember, again, there's my opposite. It's negative 5 because the hypotenuse is negative, never negative. And my x value here is positive 12 because in quadrant 4 the x is positive. Down here, this is just going to become 13 from Pythagorean theorem. And now we're going to answer these questions right here. I'm going to answer like maybe 1, maybe 2. Let you guys answer a couple, maybe answer the last one or 2. All right, for the first one is cosine. Now we know cosine. It's cosine alpha, cosine beta, minus sine alpha, sine beta. And I'm just going to use my triangles to get these. To get the cosine of alpha, cosine is adjacent, so it's negative 4 over the hypotenuse, times the cosine of beta. Now beta, it's adjacent, 12 over 13, minus sine of alpha, that's our opposite, that's 3 over 5, times the sine of beta. Again, opposite, negative 5 over 13. And I get these straight from our triangle. In simplifying, we get negative 48 over 60 minus a negative 15. Oh, that should be 65. 15 over 65. And I just combine them. Be careful. Add the opposite here. We get negative 33 over 65. And there's our answer. Now, I want you guys to do part B, and we're going to take a look at part C together because it's a tangent one. Tangent ones are always a little bit more fun for us, so let's go ahead and take a look here. All right. Now, tangent becomes this. Be careful, it's the same here. We're going to get the tangent of alpha plus the tangent of beta over 1. Be careful, on the bottom we do the opposite, minus tangent of alpha, tangent of beta. Be very careful here. Tangent, remember, is always opposite over adjacent. So for the tangent of alpha, we get negative 3 over 4, plus for beta, negative 5 over 12. On the bottom, we get 1 minus the tangent of alpha, the tangent of alpha, the tangent of alpha, again, we already have that, is negative 3 over 4 times the tangent of beta this time, which is already negative 5 over 12. And we have to simplify this. This is not very pretty, okay? So let's go ahead and work a little bit on here. The top, if you want to, just multiply the top and bottom together. I mean, get a common denominator. Just be simple. Make it 48. That's okay. We get negative 36 minus 20. The bottom, we get 1 minus 15 over 48. And if I do my common denominator on bottom, the top becomes negative 56 over 48 over my common denominator on bottom, 48, which is why I multiply them, because you're going to notice the 48s are going to cancel. We get 48 minus 15. So multiply top and bottom by the 48. Cancel, 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 cancel. We get negative 56 over 33. This one's hard. I think plugging in is easy. The arithmetic is very tricky. All right, so try these for tonight, okay? And we'll see you guys tomorrow. Thank you.